Okay, so guys, last week we stopped with the question number 11. I want you to do from question number 12 to question number 21. There is around 1, 3, 4, 5, 6, 7, 8, 9, 10 questions, right? Yeah. Start doing these questions. Once you're done with the questions, raise your hand in Zoom. I'll give you 10 minutes. No, Amar, I didn't still send. I'll send it soon, okay? Those who are done with the question, raise your hands up because I can see one hand up. How much was it, Hafsa? Umaira, yeah, you can do it on your Zoom actually. But by now, the majority of you might have been done with 12, 13, 14, no? No, but there's no purpose. So I just zoom it a bit. That's good, Hafsa. Amara, I'll send after class, okay? Others, those are still doing. Do you all want a couple of minutes more? Because I can see 12 hands up. Those are still doing. Do you all want a couple of minutes more? Understand, Hafsa. It's fine. Okay, I'll give you around 2 to 4 minutes. Those are doing this, quickly finish it off. And raise your hand in Zoom. Don't waste time. If you're done, raise your hand in Zoom so that I can get a rough analytics of how many done. Only 30 minutes, the others quicker. Okay, let's check your answers now. Those are done. Once again, if you are done, just raise your hand in Zoom. Okay. So I can see 17 of you all have raised your hands. Others, that's not a good ratio. That should have been done by now. And if there are any of you all who is not doing the questions, again, I'm telling you, there is no purpose of what do you call listening to the explanation without trying the question. Getting it correct or wrong is second. At the end of the day, try at least. So don't be lazy and don't just write Kana Parno. There are certain questions that requires working. So do the workings, all those stuffs, and do the questions gently because without doing questions, it's difficult to improve your marks. Okay, let's start. So the question number 12 is where I ask you to start from. So let's go one by one. The question number 12 says, which of the following choices correctly matches the network terms in column A with their corresponding descriptions or characteristics in column B? So there's column A and B, and they're asking us to copy match them up. Okay. So we have switch, firewall, router, and a hub. A network security system that monitors and filters incoming and outgoing traffic. So traffic means like, any communication. Okay. Traffic based on an organization's previously established security policies. Okay. If you read this answer properly, you can see it's a security system that's going to make sure it monitors and filters incoming and outgoing traffic based on organizations, blah, blah, blah. So what that means is it's kind of a person. Okay. Now, for example, network, when the data is to network from one device to another device, okay, it's action from device to device. But throughout the network, when data is traveling, there's going to be a device in the middle here. And what this person is doing is, for example, when there's a data going out and coming out and going in. For example, let's say this is the inside and the outside. When I say outside, I'm referring to the internet. Okay. So for example, let's say you're downloading a file from the internet. So that means from outside, you're getting a file to your device. Okay. So let's say data is traveling in this direction, for example, then what this device is going to do is this device is going to check this data, whatever is coming, and it's going to be like, is this data safe or not? Okay. It's like a security check. So out of all the storage device we have learned, what is the device that does that kind of a security check? Out of these answers. Perfect. Yes. What do you call? That's going to be done by the firewall. So here the answer is going to be this. An intelligent central device in a star topology that forwards data only to specific destination computer, thereby reducing unnecessary network traffic. Okay. So here we're talking about basically a star topology situation. Now in star topology, what happens? In star topology, there is a main device in the middle. Okay. In star topology, there is a main device in the middle. And to this main device, there are several computers connected. To this main device here, there are several devices connected. That's how the star topology functions now. Now, in this star topology, when there are multiple devices like this, the device we can use to connect all these to connect all the computers, there are two possible devices we can use. we can either use switch, or else apart from using switch, we have another option as well. What is the other option? Perfect. In a network, if you want to connect multiple computers together like this, we can either use switch or else we can use hub. Okay, we can use switch or we can use hub. Now, the main difference of using switch and hub is we know in switch, we can control the access. For example, let's say we have these computers as A, B, and C. So if I have ABC computers and if I'm using a switch, I can tell, okay, send the data only from A to B or send the data only from A to C. Don't allow other person to access. I can control that part using a switch. So here they're talking about that idea. They're saying you can, what you call, what you call data is here forwarded only to specific destination computers, which means without sending the data to all the computers, we're going to send the data only for a specific computer. That is basically done by the switch. Next, internet working device that connects completely different networks together and determines the most efficient path for data packets using IP address. All basic hardware devices that broadcast incoming data packets to the all kind of person regardless of the destination. Okay. So internet working device that connects complete different networks together. So here they're talking about what you call connecting multiple networks together and determine the most efficient path for data packets using IP addresses. Okay. So basically this is talking about, for example, let's say we have two networks. So let's say I have a network here. And let's say this network have three devices. A network is basically a collection of computers connected with each other. Okay. So let's say I have a network here with three devices. And let's say I have another network here with another 3 or 4 devices. Now these two are two different networks. Okay. These two are two different networks. Now if I want, I can connect both of these networks together. And the device we use to connect multiple networks together, that is what we call as a router. So router is used to connect multiple devices together. Now here, if you notice, I have used all the devices wiredly, but you can set up it wirelessly as well. So router is used to connect devices in a wired way together. So answer there is router. And a basic hardware device that broadcasts incoming data packets to all the connected ports simultaneously, regardless of the destination. So what do you mean by that is, there is a hardware device, it seems. And this device, for example, let's say data is coming from one computer. So let's say this is one computer. And from here, data is coming. So when the data is coming, this hardware device will send that data to all the devices, no matter whether you want it or not. Okay, so he also will get the access, he also will get the data, he also will get the data. So you can't control who is getting the data. Everyone connected will get the data. That's called that can be done using the hub. In switch, I can control. In hub, you can't control. It will be sending for everyone. So that's when we connected like this. So if you match them together, it's going to be 1Q, 2P, 3R, 4S. Is the first one the answer? 1Q wrong, 1Q, 1Q, 2P. First one, right? Okay. So if you got the first one correct, mark it correct, put 1 mark there. If you have any questions, drop your questions in the chat. Perfect. Okay, next. Which of the following alternative correctly pairs a device with a signal type shown in the A and B respectively? Okay, let's see. So we can see here what you call A and B. And you can see here they're talking about two signals. Now, when we talk about computers, we learn that we can classify computers based on two categories. What are the two categories we learned you can classify computers based on? In the second lesson, I think we learned the beginning itself. We learned that we can classify computers based on two things. What are they? Why is my device playing the fool? It's not smooth. Perfect. We learned that we can classify computers based on two categories. One is basically based on size, and the other one is basically based on technology. These are two categories we actually learned in the last class. Okay. Or last class, I mean the beginning few classes in the grade 10. Now, in terms of sizes, there are four computers we have. And what is the name of the largest size computers? Again, when you take size, not only physical size, just like the physical size is big, even the power, like the computer is more powerful as well. So what is the big computer that's very powerful? Perfect. So yes, the big computer is very powerful. We call that as supercomputer. That's the largest in size. And from that onward, the size keeps on decreasing, where we have the, yes, we have the mainframe computer, and then we have the, my mouse dancing. We have the mini computer. Am I having multiple tabs running in the background? Nothing big is going on here. I've closed it. No. Nothing big is going on here. Okay, it's mini computer. And then we have the microcomputers. So these are the, what do you call, four classification in terms of size. In terms of technology, we learned three. What are they? Didn't, didn't, Perfect. Not bad. Some of you all have brains. I thought all of your brains now might have got corroded and it's sleeping because of holidays. Yeah, by the way, all have holidays at school, right, this month? You're jobless at home, no? So wait, that means I can do extra class for in the morning also, no? Oh yeah, I completely forgot about it. I seriously completely forgot about it. Yeah, you're a jobless at home? Some of your school sad life. So yeah, based on technology, we have three categories. One is called analog computers. But cool, yeah, for Pacha point you were saying. Analog computers. I have classes, not in the morning, no. Sad life for Mera. Ah, really? Yeah, for digital computers and then hybrid computers. What class my Islam says put in the morning? His theory class he put in the morning? Yes, Hannah. We are not jobless. Ootle vele. Enna vele. Udupu kalura vele. I did not know Rizlan just shifted the class 10 in the morning. That's why the bugger is nicely having time. You're talking about Saturday, Sundays, no man. I'm talking about the online class. He's online, what do you call, weekdays you're free in the morning, no? Jobless fellows. Let's see. What do you call? Yeah. So you all learned about the classification of technology as analog, digital, and hybrid. Exactly, Hafsa. So what do you call in terms of these three classifications, how it gets classified is based on the technology used. So when you're taking communications between the computer, okay, when data is transferring from one device to another device, the data can be the signal that's been transferred can be transferred in different forms. Okay. So the signal that is transferring, signal is when you talk about signal, we're mainly talking about like current. Okay. So that signal that's transferred from one device to another device, it transfers in different ways. And one of the ways the signals can be transferred is by something called as analog signals. And another way the signal can be transferred from one device to another device is something called digital signals. So what I mean by one device to another device is, for example, let's say we have a thermometer. Okay. Do you all know what is the purpose of thermometer? What's the purpose of thermometer? Ah, is it they have? Yeah, jobless, but not you, so you won't do. That's true enough. Yeah, what's the purpose of thermometer? Chutta chutta mukadde. You all don't know the purpose of thermometer? Yeah. What the hell, man? Don't call yourself as kids. I mean, humans. See, sad life. So mostly in thermometers, you might have something like this, okay, where there is a sensor here, okay. So there's like a thing called as a sensor here. So what this sensor will do is the sensor will collect certain data, and this data will be sent to this display you have here. Okay, I'm talking about this sensor, okay, electronic thermometer. So what happens is it will check the temperature, and the temperature will be checked, and the temperature will be sent. No? So when the data is traveling from this sensor, the data travels in mostly in the form of analog signals, which means numbers. Okay, it will not go in ones or zeros, it will go in numbers, right? So the main difference of analog signals and digital signals is it's a temperature, man, thermometer, sorry. So the main difference of analog signals and digital signals is in digital signals, there are only two possible values. One is one, other one is zero. But if you take analog signals, the values can be a varying value. You can have varying values. So what I mean by varying values is, for example, let's say if you're measuring temperature, temperature can be a value, not just 0 or 1, it can be a value more than that as well. So if I'm plotting a graph, okay, if I'm plotting a graph, now like temperature, all those stuffs can be, or like, humidity level, all those stuffs can be a value that's increasing, decreasing, decreasing, kilo. It can be a value that has variations, okay? It can be a value that has variations. I can go from 1 to 3, let's say 1, let's say 2, let's say 3 kilo. I can have varying values like this, increase and decrease. Okay. But if you take digital signals, a digital signal can have just two possible values. Hey, I'm an idiot, man. You don't start zero from here, start zero from here. None of you even pointed that, no. That shows that you all are idiots. Not bad. I used to saw, but you didn't tell, no. Didn't, 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 didn't. So let's say, for example, the x-axis is talking about time. Okay. So for example, if I take digital signals, it will be either 1 or else 0. Okay, it will be 1 or else 0. So there will not be a, what do you call this one? There will not be like a curve like this. Okay, you can't have 0 0.5, 0 0.2, can't learn. Either it's 1 or else 0. Okay, it's either 1 or 0. Only those two possible values it can have. So normally you take current that's passed between sensors that is used to detect stuffs. Like for example, there are certain sensors that are used to detect are there movements. So what those sensors will do is if it detects a movement, it will get the value 1. If there's no movement, 0. So those kind of sensors, it has two values, 1 or 0, 1 or 0. So if a computer can handle with only 1 and 0 values, those kind of computers are called digital computers. If a computer can handle these varying values, which you can get from sensors, if it can process the data obtained like without getting ones and zeros values, if it can process these data that's having varying values, those computers are called analog computers. Okay. So if you look at the chart given here, you can see image A and B. Image A has only two values. So mostly this will be 0 and this will be 1. Okay. So it will be either 1 or else 0. 1 or else 0. So how do you call this type of signal as? Is it Hara? Not exactly. Correct. If you're having this kind of a value, it's called the digital signals. And then if you're having values like this, the varying values, how do you call this? Perfect. Analog signals. Having varying values like this, they're called analog signals. So the question says, which of the following alternatives correctly repairs a device with the signal type shown in image A and B respectively? Okay. Is desktop computer digital? Yes. Thermometer analog? Yes. Thermometer is digital. Laptop computer analog? No. Is smartwatch digital, desktop analog? Smartwatch is actually okay. In certain smartwatch, you actually have this ones. Certain smartwatch has the ability to check your heartbeat. Okay. So under which category do you think smartwatch will come under? Those smartwatch that can check your heartbeat. Um, yes. Smartwatch is an example for hybrid computers because hybrid computer is basically the combination of analog plus digital. So only that part of the ability to measure what do you call the ability to measure heartbeat, that part is analog. But the remaining all the applications you can run, you can take calls, you can send messages, all those stuffs comes under digital computers. So if you take those smartwatch has a combination of analog and digital both. Okay, so that's called a hybrid computer. That's a hybrid. Here both are digital. Desktop computer again digital. Hybrid signals are computers that can include both analog as well as digital. Okay. Then fourth answer, landline telephone and smart mobile phone. Smart mobile phone actually has digital, and your landline phone actually has. Do you all know what is landline phone? Landline phone has actually analog signals. This is what the landline phone is. For the people who don't know, we call them as land phone. This is that land phone. This wire ekakkai. This same wire will go up to the road. In the road, you have these lamppost. The lamppost, the wire will be connected. So these are landline phones. The land phones basically. Good job. So these landline phones, they actually have analog signals. Huh? Hmm. So the answer that contains both correctly. First image digital, second image analog. That's the answer number one. So if you got the answer correct, mark it correct, put 1 mark there. If you have any questions, drop in the chat. Next question. Question number 14. Consider the number 71 base x. Here x represents the base value of that number system. What is the correct answer regarding the number system that the number 71 base x can belong to? Okay. Basically, they have given a number called 71. We currently don't know what is the base. So the question is asking what number systems the base could be. Now, could this number be something like this? Can we have this number as a binary number, 71 base 2? Is this answer correct? If I write 71 base 2, is this number a valid number? Yes or no? No. What is the reason? Because binary can have only what and what numbers. Perfect. Binaries can have only zeros and ones. So therefore, it can't be a binary answer. Answer number 4 has binary, so definitely the answer is wrong. Next. Can it be 71 base 8? 8 means octal. Can it be octal? Yes. If you take octal, if you take binary, binary has a number only 0 and 1. If you take octal, yes, octal has numbers from 0 to 7. So using numbers from 0 to 7, you can form numbers. It's like, for example, if you want to form an English word, we have the alphabet, right? So you can use any letters from the alphabet and you can form words. Likewise, to form numbers in binary, the alphabet is like having only 0 and 1 as the values. So using 0 and 1, you can form the numbers. For octal numbers, you can use one of these characters, and using one of these characters, you can form numbers. And likewise, if you take for decimal, decimal we have from 0 to how much? Correct. If you take decimal, we have from 0 to 9. And hexadecimal, we have from 0 to 9. And apart from having characters from 0 to 9, in hexadecimal, we have letters as well. So what are those letters from A to? Perfect. In hexadecimal, apart from numbers from 0 to 9, we have letters from 0 to F as well. So out of the given answers, the number 71, the number 7 and the number 1, these two are characters that can come in octal, that can come in decimal, that can come in hexadecimal as well. So answer is only octal, decimal and hexadecimal, the option number 3. You got that correct? Mark it correct. One mark there. If you have any doubts, drop in the chat. I'll go for the next one. Which of the following statement regarding the BCD coding system is correct? Okay, let's see. One decimal digit is represented using 5 bits. Wrong. Not 5 bits. Using how many bits? You don't use 5 bits. To represent one character, how many bits are used? Correct. We don't use 5 bits. Instead, we use 4 bits. So for example, if I have a decimal number called 27, if I convert it to BCD, okay. So if I basically BCD is a method you can use to convert decimal numbers to binary, yeah, or values to binary. So using the BCD method, if I convert this number to binary, what will happen is every character is represented using 4 bits. So number 2 will be represented as 0010. Number 7 will be represented as 0111. I'm keeping a small space for just to show you the difference. But in reality, we don't keep a space. We write the whole thing as one number. 0 blah 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 is a valid and correct BCD code. Okay. If you want to check, is it a valid and correct BCD code? There are two things you have to check. First thing you have to check is the number of digits we have. Is it a multiple of 4? Let's first check that below. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 digits here. If you look at the answer number 2, there are 8 digits. So based on the number of digits, tell me, based on the number of digits, is it valid? Can't use commas also? No, you can't. Based on the number of digits. Now, if you look at the number there, we have 00, 111, sorry, 111, 00. So there are 8 digits here. So if there are 8 digits, yes, it is valid. Because in BCD, every character is represented using 4 digits or 4 bits. So these 4 bits has to represent one character. These 4 bits has to represent another character. Now comes the next question. BCD is a coding system that is used to represent only decimal numbers. Okay, BCD is a coding system that is used to represent only decimal numbers. In terms of decimal numbers, the smallest decimal number we have is 0, and the largest decimal number we have is 9. Okay, these are the range of decimal numbers. And if you take the value of 9 in binary, if you convert number 9 to binary, number 9 in binary is equal to 1001. The value of number 9 in binary is equal to 1001. So here you can see they are given 0011 and 1100. If you convert both of them from binary, if you convert them to decimal, what you should do is to convert them from binary to decimal. You can use a long form if you want. Okay, to convert from binary to decimal, you can use a long method you all have learned, or else there's a shortcut when it comes to BCD as well. Okay, to convert to binary to decimal, you can use a long form if you want, or if you're lazy like me, you can use a shortcut. I'll just use a shortcut and show you. Just segregate both the numbers separately. After you segregate both the numbers separately, just write the place values. You have to take these two as two separate numbers. This is one number, that's another number. And below these numbers, write their place values. So it's a binary number. So place values goes as 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. Okay, so these 1, 2, 4, 8, it represents the place value of that number. Like in decimal numbers, we have ones place, tens place, hundreds place, thousand place. Likewise, in binary numbers, the place values goes as 1, 2, 4, 8. Basically, it's 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. That's how I obtained them. Anyways, so basically what I did is I took both the numbers separately and below every digit I wrote 1, 2, 4, 8. Wherever 0 is there, you cut the place value. Wherever 0 is there, cut the place value and write the sum of the remaining. So here sum of the remaining is 2 plus 1, 3. Here sum of remaining is 8 plus 4, 12. Give me a moment, guys. Hello? Hmm. Sorry, what you call it, a small clarification check. What I was telling you all was, in terms of numbers, when you take after you cut the place value, whenever the number is 0, you cut the place value, and then you write the sum of the remaining. So here 8 and 4 is remaining, sum of remaining is 12. Here 2 and 1 is remaining, sum of remaining is 3. Okay. Now, if you take 3, if you ask, is 3 a valid decimal number? Then yes. But if you take 12, is 12 a valid decimal digit? Here we are talking about 4 bits representing one digit. 4 bits representing one digit. Okay. And that digit has to be a decimal digit. So if you take what you call 12, is 12 a valid decimal number? No. 9 is the largest number decimal value can have. So therefore, 1100, this is actually not a number that you have in decimal, because decimal's largest number is 1001. So now you might be asking, I mean, if you can remember the BCD numbers, you might know in BCD what happens is the values we have are like this. No? These are the BCD values we have. For example, if I take from 0 to 9, okay, if I take the numbers from 0 to 9, these are the numbers I have in BCD. 4 zeros, 0001, 0010, 0011, 0110, 0101, 0110, then 0111, then 1000, 1001. These are values we have in BCD. Okay. Now you might be wondering, what about the other numbers? Now, for example, using 4 bits, we actually can form numbers like this. We can form numbers like 1010. We can form numbers like 101, 8, 9, 9, 10, 11, and 12, and 13, and 12, 13, 14, and 15. Using 4 bits, we can form these numbers as well. But if you keep in mind, sorry, if you what you call convert these numbers to back to decimal, the numbers you'll be getting is 10, 11, 12, 13, 14. But decimal, we don't have those numbers. In decimal, the largest number we have is 9. I mean, largest character we have is 9. So therefore, there's a special name for this. We actually call these as forbidden numbers. when it comes to BCD, in BCD, the only valid numbers are from here to here. These are the valid BCD numbers. These are the valid BCD values. And these values are actually called forbidden numbers or forbidden values. Okay. So when you're checking, is this number a valid BCD number or not? How you check is it a valid BCD number is it should come within this range of 0 to 9. So if it's within this range of 0 to 9, then it's correct. But if it's out of that range, then that number is wrong. So double one double zero, that's represent number 12. We don't have a number called 12 in decimal. The largest number in decimal is 9. So therefore, that answer is wrong. Is that clear of you? There are two ways to check is the number valid. One is number of digits. It has to be a multiple of 4. Second thing is the value should be between 0 to 9. You keep that in your mind. I'll just write it here. Number of digits. Number of digits should be a multiple of 4. Second thing is the value 4 bits are representing. The value each 4 bits are representing. The value each 4 bits are representing should be between 0 to 9. Okay, that's how it works. Third one, the decimal value of the BCD code blah 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 is 39. Let's check. So first of all, you segregate by 4 bits by 4 bits. Okay. And segregate is by 4 bits by 4 bits. You will have the numbers, let's say 0011. And the other number you will have is 1001. Again, you can use the same method I used earlier. Just write 1248 below every number. Wherever 0 is there, cut the place value. Write the sum of the remaining. 8 plus 1, 9. 2 plus 1, 3. Answer is 39. Yes, the answer is correct. Actually, once you've done several questions, like practice several questions, you can do this in your mind. If you notice, when I wrote these numbers from 0 to 9, I wrote it very faster. It is not that I had not by hearted all these numbers. Basically, I was processing that part of 1248, 1248. Okay, so I was like, okay, how can you form 3 using 1248? How can you form 4 using 1248? So that's how it works. The fourth one, every 4-bit every 4-bit combination from 0011 to 11 represents a valid BCD digit. Okay, is the fourth one correct? Yes or no? Is the fourth one correct? Yes or no? What do you mean by I don't know? The question, I'll explain what the question is mean. The question is saying every 4-bit binary combination from 0011 to fobble 1 represents a valid BCD digit. That means from fobble 0, this is 4 zeros, and this is fobble 1. So they are saying from 0000 to 1111, all these numbers are valid. Are all these valid? Exactly. Answer is no. So only up to where it is valid? Only up to? Perfect. Only up to 1001 is valid. Others all are forbidden. I threw my phone by mistake. It's alive. So yeah, the answer is gonna be the water dinner still goes like it's still live. Alhamdulillah. Anyways, yeah, the answer is the third one. Digital color is represented as RGB. What is the correct hexadecimal color code? Okay, let's see. By the way, if you got the answer correct, mark it correct, put one mark there. Always, when not doing MCQ questions, have this habit of finding the wrong answers. Like, you have a reason why this is wrong, why this is wrong, why this is wrong. So once you have figured out the reasons properly, then the remaining answer is definitely correct. That's how you master MCQs basically. Nuska, you mean the 16th one? Then that's the elimination method, right? Yeah. Now you dropped your phone. Yes. A digital color is represented as RGB. What is the correct hexadecimal color code? Okay, let's find the answer. So basically, representing colors the computer, there are two color patterns. One is RGB and one is hexadecimal color codes. Actually, there is another one more as well. Apart from RGB and hexadecimal color code, there is something called HSL or something, if I'm not wrong. I'll double check on that. Anyways, the question says the RGB value is 255, 165, and 0. Now, out of these three values you have here, the first value represents the amount of red used, the second value represents the amount of green used, and third one represents the amount of blue used. Now, based on normal RGB colors, tell me, each of these values can be a number that's between how much to how much. The amount of red, the amount of green, the amount of blue is there, right? They can be a number between how much to how much. No. How can be 1 to 15, man? Already in example, they are given 165 and all. No? What's CMYK then? CMYK is something called as a color model. You can even put CMYK colors as well in computers. Normally, you're representing colors in the computer screens. Okay, the same RGB value, it can be represented as hexadecimal numbers. It's just basically same number represented two ways. It's like, for example, now RGB and CMYK are two different things. It's completely two different. RGB stands for green, blue. CMYK stands for cyan, magenta, yellow, and key is mostly black. So those are complete two different color models. Here color is formed using these three colors. Here color is formed using these four colors. So these are two different ways of how colors can be formed. Right? Here colors are formed by the combination of red, green, and blue. And here colors are formed by the combination of cyan, magenta, and yellow. So here the colors are formed in two different ways. But when you take what you call two ways of representing color codes, when you take color codes, okay, we'll take color codes. These color codes can be represented in different ways. Now, what I mean by color code is, let's say we have a RGB value. We'll take the RGB value called red. The RGB value red, it can be represented. So the color called red, it can be represented in RGB values like this: 255, 0, 0. The same color, the same value can be represented in hexadecimal color code as hashtag FF0000. So hexadecimal color code is basically a way of representing that value. It's the same value only. It's both the same value represented in two different ways. Now, CMYK and RGB are not the same values. It's two different values. RGB and hexadecimal, it's the same value represented in two different ways. Something like, for example, let's say the word called Yusuf Riaz, or let's say this is my full name. Okay. The same full name, I can write it like this, or I can write it like this as well. Actually, I'm missing one word here. So it's the same value. I'm writing two different names, two different ways. But this also represents same thing. This also represents same thing. So it's the same thing. So RGB and hexadecimal, what you called color codes, are just two ways of representing the same color. But RGB and CMYK, they're not two ways of representing, they are two ways of forming the color. So you can form a color by combining red, green, blue, or you can form a color by cyan, magenta, yellow. So these are two ways to form a color. Ways to form a color by combining. And these two are two ways of representing a RGB color. Both are RGB, yeah? Ways of representing RGB colors. Make sense? Haja? I mean, Fatima? So, right, it's the magical powers. I'll show how to find it. Okay. So, in terms of how to convert, now, if you take the hexadecimal color code is a color code that starts with hashtag in front. Actually, apart from using hashtag in front, there's another way you could, there's another symbol you can use as well. Did I teach it for grade 10s? I thought it has extra factor. You can remember, like, yeah, I thought it. Apart from hashtag, there's another value you can use as well in front. That's called the ampersand symbol. So it's called and H. Okay, this is called the ampersand symbol. Huh? This is the ampersand and H symbol. So it's ampersand and H. So you can use both the ways, but it's very, very, very rare that they use the second method. Most they might use the first method. Okay. And what happens is after the hashtag, there will be 6 characters. Out of these 6 characters, the first 2 characters will represent the amount of red used, the middle 2 characters will represent the amount of green used, and the last 2 characters will represent the amount of blue used. Okay. So for example, if you want to find what these 6 characters are, what you should do is you convert from decimal to hexadecimal. You convert from decimal to hexadecimal. So for example, if I convert 255 base 10, if I convert this to hexadecimal, the answer is going to be FF base 16. If I convert 165 from decimal to hexadecimal, I'll show you the method how do you do it. The same usual division method only. Just take 165, divide by 16. 16 times 10 is 160. 5 remains. Divide by 16. 16 times 0 is 0. 10 remains. 10 is equal to A. Find the remainders from bottom to top. Answer is basically A5 base 16. The normal usual division method is there, right? That's the method you find the answer from. So what you call 165, if you convert that to hexadecimal, the answer is A5 base 16. And then 0 base 16, if you convert from, sorry, 0 base 10, if you convert 0 base 10 to hexadecimal, that's going to be equal to 0 again. So 0 is equal to 0 in all number systems. Therefore, I'm not showing you all the method. But 0 base 10, if you convert that hexadecimal, also it's going to be 0 base 16. Okay. So if you want to convert from RGB to hexadecimal, if you want to do the conversion, the first step is you have to find out the hexadecimal values equivalent for all these numbers separately. So after you find out the hexadecimal them to make sure your answer is in 2 digits. Now the amount of red use is 255. Do I have the answer in 2 digit? Yes. The amount of green use is 165. Do I have the answer in 2 digit? Yes. The amount of blue use is 0. I have that in 1 digit. So tell me, how can I write this number 0 in 2 digits without changing its value? Without changing the value, I represent the same number in 2 digits. Correct. I can represent that as 00 base 16. So then the RGB value is going to be FF A5 00. So these are the hexadecimal color code. Hashtag FF A5 00. So in his answer, you can also write this as hashtag and FF A5 00. Both are correct. Okay. But the idea is basically that In a hexadecimal color code, the first two values represent the amount of red used, middle two represents the amount of green used, last two represent the amount of blue used. To find the respective values, you just have to convert from decimal to hexadecimal. Is that clear? FFA500. This is the answer. Okay. Now I'll tell you what's the short form of how do you do this question. Now, this is how you should do for the part two. In part two, you have to show all these methods and you have to give it. How do you find a zero? Same, just divide here. Just take 0, divide by 16. 16 times 0 is 0. 0 remains. So basically do the division until you get 0. Zero in decimal is, I mean, the value number 0 is equal to 0 in all other number systems as well. Like 0 base 2 is equal to 0 base 8 to 0 base 16. All are basically 0. Makes sense? Not that 2 0 you got. It's something like, for example, I give you the number called 7. If I ask to represent 7 in 2 digits without changing the value, you can write something like this, right? Now this is also 7, this is also 7. Okay. If I ask you in 3 digits without changing the value, you can represent that as 007. So here the value, and here the value. They're all the same. You just add 0 in the back, 0 on the left side to increase the number of digits and retain the same value. So value is same, number of digits are different. Make sense, Abba? So I just added a 0 here in front. Why we increase the value? Because in hexadecimal, 2 digits are used to represent every color. So if I don't use 2 digits there, I will not have a total of 6 digits. It's compulsory to have 6 digits. It's compulsory for the first 2 digits to be red, middle 2 digits to be green, and last 2 digits to be blue. So that's a format. The format is always have 2 by 2 by 2. So in situation, we don't have a complete 2-digit answer. We add a 0 to make sure it's 2 digits. Make sense? Perfect. Okay, now I'll tell you how you do this question fast in MCQ. In MCQ, you don't have time to basically convert everything at once. Okay. So what you can do is you can look at the value here and you can see, okay, the last value mentioned is, let's say 0. Now, one thing you have to keep in your mind is 0 in binary is equal to 0 in decimal, and that's equal to 0 in octal, and that's equal to 0 in hexadecimal. All these numbers, 0 is equal to 0. Wherever you go, 0 is 0. So if you go through the hexadecimal numbers, you should have the idea that in hexadecimal number, the first 2 digits is representing red, the middle 2 digits is representing green, and last 2 is representing blue. So if you compare the given answers, you can see, okay, the first one, if you see, are we having 0, 0? Correct. Second one, are we having 0, 0? No. Third one, are we having 0 and 0? Correct. Last one, are we having 0 and 0? No. So from this itself, you should know that second answer and fourth answer is wrong. Is that part clear of you? How I found out second answer and fourth answer is wrong? Is that part clear? But what if we have another number without 0? That's what I gave you here. See, if I have a number 7, I can make number 7 become 2 digits by adding a 0 in front. So this is also 7. This is also 7, right, Fatima? At the end of the day, you want 2 digits. So you add a 0 in front. Perfect. Okay. The next thing you have to keep in mind is in hexadecimal, the largest number we have is 255. And if you have done several questions, you will know 255 is equal to FF in base 16. Like this is basically because I've done several questions, I know the idea. But once you have done several questions, you should know the largest number in hexadecimal is 255 and that's equal to FF. The largest number we can have is FF. So now what you can do is you can convert all the value. You can compare the now remaining answers we have is 1 and 3 now. So you can compare 1 and 3 and see in which one do we have FF. So here we have FF, here we don't have FF. So this is definitely wrong with the correct answer. So without even doing any conversion, without a single conversion also, you can find the answer if you can remember these stuffs. This is how you do questions fast in MCQs. Is always the value of blue they give is going to be 1 digit, not 1 digit. Any of these can be 1 digit. Now, for example, let's say if I ask you to find the number of something like this, if I have RGB value like this, let's say I have a RGB value like this. Let's say RGB value is 7, 20, so 7, 15, 3. Okay. Now, if I have a RGB value like this, if you convert 7 Okay, if you convert 7 from decimal to hexadecimal, divide 7 by 16. 16 times 0 is 0. 7 remains. So answer is 7 base 16. If you convert number 15 to what you call hexadecimal, 16 times 0 is 0. 15 remains. In hexadecimal, 15 is equal to F. So answer is basically F base 16. If I convert number 3 from hexadecimal to decimal, 16 times 0 is 0. 3 remains. So answer is 3 base 16. Now if you look at these numbers, all my answers are single digit. So when I'm writing my final answer, if you write something as hashtag 7F3, is this correct? Yes, this one. Is the answer correct? Hashtag 7F3, is that correct? No. Because I told you in hexadecimal, we have a total of 6 digits. And out of these 6 digits, the first 2 digits are red, the middle 2 digits are green, and last 2 digits are blue. So therefore, we are making sure that our answer is always in 2 digits. So I can write this 7 as 07 base 16. I can write F as 0F base 16. I can write 3 as 03 base 16. So the correct answer is basically hashtag 07, 0F, and 03. Is that clear? So not only the last digit, any digit can have a single number. The point is your total final answer has to have a 6 digits, where the first 2 digits are representing red, middle 2 digits are representing green, and last 2 digits are representing blue. We should only divide by 16. Is there any other methods you can convert from decimal to hexadecimal? What do we do if red doesn't hold 255? As in, you mean in this question, if we had the same thing without red being 255? Mostly in MCQs, they'll give you a hint to make your work easy. Okay, like I told you, you see all these questions without doing the correct answer, there are ways you can find it. So if you don't have any more hints, then go for the method of finding the answer. Like do the conversion. Like for example, let's say they gave 245 there, convert and see. But again, you don't have to convert both of them in that situation. You can just convert one person and see. Okay. How? I'll show you. So for example, let's say the number was something like this. Let's say they gave the number like this. Okay. If they gave the number as 255, 165, 0. Forget about the first number, Fatima. Let's say I'm going to compare the last two numbers. Okay. If I'm going to compare the last two numbers, you can see we have 0 here. And I know 0 in decimal is equal to, this is 0 in decimal. I know 0 in decimal is equal to 0 in all other number systems as well. So therefore, I compare all the answer and see which one do we have 0 at last. And I can notice here, this one doesn't have and this one doesn't have. So I eliminate these two answers. Basically, I'm filtering my answers to make my work easy. Are you clear how I cut these two people? Okay. Now, for example, let's say these two numbers, let's say this was, let's say the what you call answer number 3 and now we have filtered, now we have the filter with answer number 1 and 3. So let's say out of answer 1 and 3, if I want to find the answer, in this question, I have the numbers 255. And I know 255 is equal to FF. Again, you get this by practice. So therefore, I can compare the first two numbers and see, are they same? I mean, are they FF? And I know this is correct and this is wrong. Okay. So if it was 255, I can directly find. But let's say if it was not 255, for example, let's say we had a different number. If you had a different number, then do the conversion. For example, let's say we had 165. So if I had 165, I'm going to convert 165 to from hexadecimal. Sorry, from decimal, I'm going to convert to hexadecimal. So if I convert 165, I have 10 times 16 times 10 is 160. 5 remains. 16 times 0 is 0. 10 remains. 10 is equal to A. So answer is basically A5 base 16. So I'll compare the answer and see which one has A5. Then I will know what the correct answer is. Sometimes, even after you do that, find the answer, then you do the next one. I'm saying converting is a definite. If you do the conversion, you're going to get answer that's definitely correct. But converting takes time. So before you convert, see is there a way you can find the answer quickly. If you can find the answer quickly, do in a quick way. If you can't find the answer quickly, then come back to the original way you have to do it. The correct way you should do is technically this is the correct way, the whole conversion. But the point is it takes time. So to save time, I'm asking you to go in the smallest way if it's possible. Only if it's possible. Make sense, Padma? And Ala, did you understand how I did it? Amal as well? Perfect. So here the answer is basically this. Which of the following shows the given memory device in descending order of access speed? Okay. Descending order means big to small. Okay. So the bigger speed is going to come first. The smallest speed is going to come down, which means, for example, let's say something is going 1 kilometers per hour, that's small. 50 kilometers per hour, that's fast. No? Again, we don't measure computer speed in hours for kilometers per hour. Come back to the point. Oh, wait, good question. What is the unit used to measure the computer speed? Okay, good. You all have brains. Computer speed is measured in HZ, MHZ, and GHZ. Huh? HZ stands for Hertz, MHZ stands for megahertz, GHZ stands for gigahertz. This is a base unit. Okay. HZ is a base unit, but majority of the nowadays computers you buy, you will see the speed in the form of GHZ. Come back to the point. So the largest number is going to come first, smallest number is going to come the last. So fastest is first, and slowest is last. So out of all the storage device we have, the fastest storage device, okay, in terms of speed, if you're wondering how is speed measured, speed is basically talking about how the communication happens with the CPU. Because at the end of the day, CPU is only going to process the data. Okay, at the end of the day, the CPU is the one who's going to process data. So when I talk about speed, mostly we are talking about the time taken to communicate with the CPU and process the data. Okay, to communicate with the CPU and process the data. So now practically tell me, a person who is with the CPU, can this person communicate with the CPU faster? Or the person who is away from the CPU, can this person communicate with the CPU faster? Who can communicate with the CPU faster? With the CPU or away from the CPU? Exactly. Like practically think, for example, there's a person you want to talk to. Okay, if you're close to that person, you can talk more faster than if you're away from them. Right? Now, on the other hand side, if you take CPU, your CPU has three main components. Out of those three main components, tell me, what is the component that's used to store data? CPU has three components, ALU, CU, and memory registers. So which one is used to store data? Exactly. The memory register is what we use to store data. So memory register, also known as register memory, that's a memory that's already there inside the CPU. So because it's there inside the CPU, it can communicate with the CPU comparatively very faster. So the fastest storage device we have is actually register memory. It can read data and write data very, very faster because at the end of the day, CPU is only going to do that action. And because it's very close to CPU, it can do comparatively faster. So the fastest is register memory. If you go through the answers, you can see only the second answer and fourth answer has register memory in the first. Tell me, I all clear with how I filtered and got the answers second and fourth, first of all? Okay, perfect. Now, if you all can remember the example I told you all about how data is stored in the computer, okay? I gave it a nice example where I told initially all the data are stored in one place. And then when you're consuming that data, you take this data to one place. And then from this place, you consume the data. What example am I referring to? Let's see if you can remember. Who is this big fellow here? Well, I've forgotten so fast. Yeah. Okay, I'll give a hint. What is a place we used to store food? I said we used to store food for a long time. When we are consuming it, we take to one place and then we consume it. Correct. Yes, the fridge. And what is this? What is circle? Well, I've forgotten, huh? Yeah, the plate. And this? Very bad. The mouth. Thick. Very bad. So by default, all of your, let's take food below. By default, you store all the food in the fridge. For long-term purpose, you store the food in the fridge. Okay. When you're consuming the food, I told you, what you do is you don't take your hand and eat directly. You don't put your mouth like a dog and eat directly. What you might do, that food you have, you might sometimes serve it onto a plate or serve it onto something else. Okay, let's say you have like a, what do you call a dish, and you might serve it to the dish before you consume, right? And in your dish, you're not going to consume all the food. Now, for example, let's say in the fridge, you have a collection of food. Like you have, for example, let's say in one big plate, you have, so in one big sawan, you have all the rice, another big, what do you call, pots and pan, you have all the curries. You're not going to take all the curries, all the food and eat. You're just going to serve the amount you want only. So the plate will have not every food that's there in the fridge, but the plate will have only the food that you're consuming. And while you're consuming also, you can't consume the whole plate at once. You can't eat the whole food at once. So you eat mouth by mouth. So you take one mouth using a hand, you eat. One little, you eat. Okay. I told you, so you can eat using a hand, you can eat using a spoon, that's your wish. But I told you that this is the one that we used to store the food permanently. This is used to store the food that's consuming. Okay. What you need currently. So that's the food you are storing permanently or storing long term. And here storing temporarily. And here it's consuming, kind of. So while you're eating, you can store it in the food and eat. Okay. And I told you the place used to store data permanently, like your long-term memory, like the fridge. That's called what? What is the example I gave you? Then you know the answer, sorry, Fatima. I want you all to remember the past. You can, I thought about this in the second lesson. This permanently is what? Yeah, temporarily correct. Permanently, it's your secondary memory. It can be a hard disk. It can be any storage device. So any storage device you can use to store data permanently. Example, hard disk, pen drive, anything it can be. Okay. So whatever data that's then hard disk, when you're consuming, you might take it to your plate. So that's temporary storing. What do you call this as? While you're consuming. Okay, while you're consuming, you're temporarily storing it where? In the, yeah, it's temporarily stored inside the RAM. And then while you're consuming, in your mouth, you're munching the food and you're going to give the food to your, what do you call, digestive system. So you're munching and consuming the food, you're processing the food. So who is going to process this food while it's used? Your computer, who is processing the data? Who is processing the data in the computer? Processing. Only one processor I'll have learned so far. And you can't remember that one single processor. Where did cache memory process data, man? Cache memory is storing data. It never processes the data. Who is processing data? Exactly. Only one person is processing data. That's the CPU. So, if you're wondering where is cache memory here, cache memory is a person, cache memory is that spoon, or cache memory is that hand that's taking the data from here to here and from here to here. Okay. I told you, cache memory is at your hand, which is taking the food from the plate to your mouth, or from the fridge to your plate. Or it's a spoon that you use to take from here to here. So it can be a spoon, it can be a hand, it's your wish. But that's what the cache memory is basically your hand. Very bad memory man you will have. Okay. So in terms of CPU, comparatively, who is more closer? The cache memory or the basically your plate or your hand? Yeah, food equals data, correct. In this situation. So who is more closer to the CPU? Is it the RAM or is it the cache memory? Who is more closer? Is a what is are you putting a plate to your mouth? Or are you putting a hand that what goes to your mouth, man? Your plate or your hand? Hand. So who is hand here? You all are like you all have forgotten the second lesson for the week, huh? It's been just few months since we completed the lesson. I imagine you'll go for grade 11. Sad life. Who is more closer to the mouth? Is it the cash? Is it your hand, man? Your hand is taking the food from here to here. It's a very easy lesson. It's a cache memory. So what do you call after register memory? The next fastest fellow is a cache memory. So answer number two is wrong. Fourth one is RAM. RAM is third. Okay. This is how the order goes. But some people may eat off the plates that doesn't don't get offended. They don't put if they don't are they dogs to put the mouth directly? You can't even do it, man. Like how can you eat from the plate directly? Let's say you have rice. Your nose, face all will have rice, man. You can't do it. It's not possible to complete the plate then. Unless you're gonna eat like a dog, like use your tongue and tangify and then hand goes inside the mouth, food goes inside the stomach. Actually, hand doesn't go inside your mouth. Like you don't put your mouth, I can atul da nane. You stop it from here basically. The kind of yeah. Anyways, the point is simple. Your permanent storage hard disk that flow is the farthest from your fridge is the farthest fellow from the mouth. Plate is the next farthest, and how hand is the closest. So person that's used, just remember this example. Permanently storing food is fridge, right? Same thing with hard disk. Temporary storing food is a plate, right? That's how the RAM works. Only the food you're going to consume, you store it. You don't put all the food available in the fridge. Only what you're going to use, only what you're going to eat, you're going to store. And then whatever you're storing, whatever you're processing, the food that is getting processed is done by the CPU, which is your mouth. So it's all wrong. No, your second answer is correct. Register memory first, cache memory second, RAM third, hard disk fourth. Register is the fastest, cache is second fastest because that's the second closest to the CPU. RAM is the third closest. The whole hand mouth thing. The answers you all gave were wrong. Be the correct answer. Anyway, so the answer is the 17th one. So 17th one answer is the second one. I got the second one correct. Mark it correct with 1 mark. Yeah. Any questions? Drop in the chat. Next. A library wants to scan a 10-page newspaper and convert its content into an editable computer document. Okay. So there is a 10-page newspaper, it seems. You want to scan this newspaper and convert its content into an editable computer document. So that means I want to extract the text from that email. Now, for example, newspaper is going to be a scan, it's going to be like a printed document, a physical copy. So from that printed copy, I want to scan. When you take scanning, mostly scanning requires like capturing a photo of the what do you call paper or whatever. Okay, that's what it's like capturing the data. So what is the device which I can do? Not only just capture and have it now. If you look at the current PDF I'm showing you, in the current PDF, I can't, even though I have scanned the PDF, I have scanned this PDF, I have scanned the paper and I have the PDF here. I can't select the text. See, I can't select the text. I can't modify the text. Okay, I can't. Now, if you look at this PDF, in this PDF, if you notice, this word called master ID, I can select it. Okay. And if I open using an editor, I can edit this value as well. So this is like editable. But here, if you take, it's not editable, the text. So what is the scanner we have that can scan the text and you can even edit it? Basically, you can what do you call extract text from a document. You just take a photo of the document and you can extract the text. What do we have for that? Soon alpha. Correct. For that, we have this technology called OCR, optical character recognition. So using OCR, we can recognize from an image, we can extract text. Okay. And then MICR, that is what we use in bank checks. Okay, MICR, that is what you use in bank checks. And barcode reader used to scan barcode. OMR, that is used to mark a type of paper. What papers? Or what answers? Correct. It's used to mark MCQ answers. So the correct answer is the third option. Got it correct, mark it correct, 1 mark there. If any questions, drop in the chat. What does MCQ stand for? Multiple choice question. The question that has multiple choice. See, 1, 2, 3, 4, 4 options. Next, question number 19. A student needs to save the following file on a memory card. What is the minimum capacity memory card required? Okay. The current problem we have is you can see all these 4 devices. It's not always 4 options because, for example, if you go for A-level Zaki, it's 5 options. So MCQ is not always 4. In certain exams, it's 1, 2. So it's a certain exams, it's 2, certain exams, 3, 4. It depends. If you will go for A-levels, I think you'll have 5 options, if I'm not wrong. Okay. And the problem we have here is these 4 devices are there in 4 different storage units. Okay. But compare the 4 numbers and tell me, what do you think the largest file size here is? Now, we have learned different storage units, no? Bits, bytes, megabytes, kilobytes. So out of the given answers here, what is the answer that has the largest file size? What is the number that has the largest file size? Correct. It's the movie, which is 3.5 GB. 3.5 GB is the largest file size. Now, practically tell me, can you put a 3.5 GB file inside a 2 GB pen drive? No, practically you can't. So that answer is anyways eliminated. So now we have the remaining answers. And in the remaining all 3 answers, you can put the 3.5 GB file. Okay, all 3 answers, you can put the 3.5 GB. So now we have to see what is the minimum capacity required. That is, what is the smallest capacity required. If you take the balance data as we have here, now how you determine what is suitable is you just go for the next smallest one. The next smallest answer is 4 GB. Now, inside this 4 GB pen drive, let's say I have a 4 GB pen drive. Inside this 4 GB pen drive, let's say I added the movie. After I added the movie, what do you think the balance storage will be? Correct. The balance storage will be half GB, 0.5 GB is half GB. Now, 1 GB is equal to 1024 MB. We have learned that 1 GB is equal to 1024 MB. So if 1 GB is equal to 1024 MB, then half GB is equal to 512 MB. Okay. Half GB is equal to 512 MB. Within this 512 MB, can I include these 2 files? These are 2 files in MB size. Okay. There are 2 numbers given in MB. Okay. There are 2 numbers here given in MB. 50 MB plus 120 MB. If you add them together, you have 170 MB basically. Can I include this 170 inside that? Yes. So inside this 512 MB, if I add the remaining 2 files, let's say if I add the 170 MB, okay. If I add the 170 MB, now how much will be the balance? Is it 332? 330, 300, 400, 500. Yes, 332, right? Yeah, 332 MB is balance. 32, 400, yeah, 332 MB is balance. Now, the next question is, within this 332 MB, can I put the text file? Now, if you take 1 MB, 1 MB is equal to 1024 KB. 1 MB is equal to 1024 KB. So, practically, 332 MB. Okay, practically tell me 332 MB. Is it going to be more than 1024 KB or is it going to be less than 1024 KB? Now we know 1 MB is equal to 1024 KB. Using that data, tell me if I have 332 MB, 332 MB is equal to is going to be equal greater than 1024 KB or less than 1024 KB? You all need to go for a maths class. If I am telling you all that 1 kilo sugar is equal to 1,000 grams of sugar, and if I ask you, basically, if I have 332 kilos, is 332 kilos going to be more than 1,000 grams or less than 1,000 grams? Is it more than 1,000 grams or less than 1,000 grams? Yeah, I can see that. It's more than 1,000 grams. Where the hell is your brains? I'm seriously concerned. Like, use your brains, man. Don't let it rotten. Harm your brains. You're making it get a malakada. We thought you said it's 332 MB less than or more than. Yeah, that's for the question. I ask you, is 332 MB, is that less than 1024 KB or is it more than 1024 KB? Sad life. Okay, I didn't say it's 332 less than 1000 or 332 more than 1000. I said it's 332 MB more than or less than 1024 KB. Okay, come back to the question. What do you call? So again, I'm asking a question. Is 332 MB, is this a number that's more than 1024 KB or is it a number less than 1024 KB? Correct. 332 MB, that's actually greater than 1024 KB. That's a number greater. That's a number greater. Okay. So if 332 KB is, if we have 332, sorry, if we have 332 MB of space balance, in this balance space, can we store this 1 KB file? It's 1 KB. Sorry, not 300, what do you call 32 because we have 512 KB, no? So instead of 42. Correct. Because what happens here is we have a, initially we have a 4 GB file. I'll just represent graphically. Look at this. Huh? Initially we have a 4 GB pen drive. Look at the screen all of you. Okay, we have 4 GB pen drive. Out of this 4 GB pen drive, to store the movie, I'm going to allocate 3.5 GB. So that will be taking almost like, let's say, half. And this is going to be like 1.5 GB. And out of the balance half, that will be 0.7% less. Let's say one, two, three, something like this. Okay. Out of this 4 GB area, this much of area is going to go for. Okay, this orange color I have colored no. This much of area is going to go for the movie. Okay, this much of area is going to go for the movie. Yeah, that's a good calculation. What do you call it? Now, if I use 3.5 GB here for the movie, okay, for the movie, if I'm going to use 3.5 GB here, then balance I have here basically 0.5 GB, which is equal to half GB. That's 512 MB. Okay, it's 512 MB. So out of this 512 MB, the question is, can we store these three files? So if I do the presentation file and the music file, presentation and music file both are in MB, so you can add them and take together. Presentation plus MB is 170 MB. Okay, which means that's going to take less than half of the balance. The balance we have 512 MB. So 512 out of 512 MB, if I'm going to use 170 MB, that's like less than half, almost only this amount. Okay, so that is green color amount kind of scenario is going to go for the presentation plus music. Up to here is it clear for all of you? that if I have 4 GB pen drive, this much of area is going to go for the movie, and this green color portion is more than enough to store that presentation music file. Now, after we do all these stuffs, we have a small balance here, in the top. We have a small balance at the top here. If you see how much is that balance amount is equal to 342 MB. Okay, that balance amount is equal to 342 MB. Okay, after I store the first three files, the balance amount is equal to 342 MB. Now, the question here is, can we store a 1 KB file there? Okay, the question is, can we store 1 KB file there? To make the works easy, without using without using the numbers like measuring units like this, I'll use some basic measuring units. Okay. If I tell you all that I have a 342 kilos, I have a 342 kg, or let's say I'll be 342, let's say centimeters. Okay, I'm saying I have 342 centimeters space available. Okay. So within this 342 centimeter space, my question is, can I store a 1 millimeter object? Because KB is less. Okay. KB is something less. Okay. Same thing here as well. When you take MB, 1 MB is equal to 1024 KB. 1 MB is equal to 1024 KB. So for example, if I have 342 MB, 342 MB is equal to 350,208 KB. So that means in balance, I have 350,208 KB balance. So now tell me, within this 350,000 space, can I include that 1 KB file? Yes, definitely I can. I can include thousands of copies even. Okay, I can include thousands of copies even. So here, the most suitable answer is actually 4 GB. The most suitable answer is 4 GB. Right? But keep in mind, in these kind of questions, you're not supposed to do all these conversions. I did several conversions here, but none of these conversions are supposed to be done. How your mind has to process this question is, listen all of you. When your mind is processing this question, you have to first of all see what is the largest number we have here. The largest number we have is 3.5 GB. Okay, the largest number we have is 3.5 GB. So your question should be, is there any answers you can't include this 3.5 GB? First one, you can't put 3.5 GB there. Why? Because 3.5 is greater. The amount of requirement we have is greater. So that from that answer. Of the remaining answer, you go for the smallest answer available. The smallest answer we have is 4 GB. So now your question should be, okay, in a 4 GB pen drive, if I put the 3.5 GB file, how much is balance? How much is balance? Half a GB is balance. So half a GB is equal to 512 MB. So now next question has to be, can I include these numbers inside the 512 MB file? So if I add these two together, these two are coming to 170 MB. Can I include 170 here? Yes. What is the balance one? 1 KB. 1 KB is a very small amount. 1 KB is a very, very small amount. So you know that 1 KB is less than 1 MB because 1 MB is having 1024 KB. Okay, you all know 1 MB is having 1024 KB. So 1 KB is less than MB basically. Right? So your point has to be within 512 MB space, can we get these two files and a file that's less than 1 MB? So even if you take 1 MB space, even if I take, let's say, 1 MB space for that, you can ask yourself, can I include 170 plus 1 MB there? So 170 plus 1 is 171. Can we include 171 here? Yes. Okay. So that's the order of how you do these questions. Don't waste your time converting. MCQs is where you will get answers. Is that clear, all of you? Okay. So the reason why I'm doing MCQ here is basically because I know marks in part two very well marks. Like majority as well, like recent exam, 56 out of 60, 55 out of 60, more than 55 you are maintaining. But MCQs got the 28, 29, 30. One thing is you're wasting time. Second thing is, what do you call you're not finding you're not approaching a question properly. So in MCQ questions, I'm saying try as maximum to go in elimination method. That's going to make your work easy. And second thing is, Use the hints and find the answer fast. Anyways, it's already almost 7 o'clock, 4 minutes for 7 o'clock. To do these two questions, it's going to take time. So I'll do the question number 20 and 21 next week. But for now, just tell me out of 1, 2, 3, 4, 5, 6, 7, 8 marks. Yeah, out of 8 marks, how many marks I got? And those who have a question, I can stay and ask. Others, once you're done, let me know my marks, so I can leave. Again, I want all of you to do these questions. Don't just what do you call come and stare in the screen because some of you are there who was just waiting till I discuss. You all are the people who are confused with these questions. But if you had tried doing these questions earlier, things would have been more easier. Perfect. That's fine. Yeah. That's good, Mister. Yeah, that's it. It's a free class. We just get it. Normally, other people they do less hours in free class. I'm the only idiot who does more. Yes, I will share it today, Amara. I'm showing the full questions when everything you can see. Here, Alpha, 12th question is in the left side. I actually made it for you only because you will ask it at last. Okay, Fatima, give me a moment. Which lesson do you have, Suraya? Stop. Yeah, what do you call Sifat? I'll share that in the group. Fatima, give me a couple of minutes, right? Exactly. No, Suraya, there's a question of Fatima I'm going to discuss about. Yes, Samara, we have in class. Yeah, I'm not talking on the phone actually. Wait. Okay. There is one more question what I'll be discussing. If you all want, I can stay others. Just give me a couple of minutes, Fatima. I'll come to the RGB question. Okay. Others, if you have any questions, drop in the chat. If you don't have any questions, if you all want to stay for that RGB question discussion, you can stay or you can leave. Just give me a couple of minutes. I'll be back. Okay, sorry in the gap, guys. Give me more formula. Resolving a small issue. Give me a moment, guys. Wait. Okay, Fatima here, right? Fatima, here. Okay, let's do. Give me one second. Just give me 5 minutes, Fatima. I think less than 5 minutes. I'm just sorting a small code issue. Mm, okay, pray and come. Once I'm done praying, let me know. That will be better. Spray and come, let me know once you're back. Fatima, am I back? Okay, let me show you how you do it. Now, let's say we have a color like this. Okay. For example, let's say we have a RGB color code like this. 200, comma 105, comma let's say 26 or 27. Right. Now you can get questions to convert these to hexadecimal color code, no? Hexadecimal color codes. So when you're converting hexadecimal color code, how it works is you have to convert all these values individually. So what I mean by converting all these values individually is, for example, we have three numbers, So one by one, I'm going to convert them to hexadecimal. So for example, something like this. Let's say, hey, wait, I didn't actually pray. I'll quickly finish this angle. So 136 color. So what happens is I have to individually convert these to hexadecimal, right? So if I convert 200 from decimal, you have to convert hexadecimal. Keep that in mind. Huh? From decimal, we are converting to hexadecimal. So if I'm converting 200 divided by 16, 16 times 1 is 16, 4 remains 40. 16 times 3 is 32, 8 remains. Okay, so if I divide 200 by 16, the answer is 13, 8 remains. And then divide 13 by 16, 16 times 0 is 0, 13 remains. And 13 hexadecimal, 10, 11, 12, 13, A, B, C, D. So answer is D8. Now this is a basic decimal to hexadecimal conversion. So likewise, I convert all these numbers first of all separately. Okay, so I'll just change this number from 105 to, let's say, just 5. So I can use this example. Now I'm converting second number as well, number 5. So number 5, I convert to hexadecimal, 16 times 0 is 0, 5 remains. You write the answer as 5 base 16. Likewise, if I convert number 27 as well, 16 times 1 is 16, then 17, 27, 11 remains. Divide by 16, 16 times 0 is 0, 1 remains. So 11 is equal to B. So answer is basically equal to 1B base 16. First of all, tell me, are you clear how I got these three values? Okay. Now, the rule of hexadecimal color code is that every character has to be represented using 2 digits. So, for example, number 2, 200, if I convert hexadecimal, it's D8. Do I have 2 digits? Yes. Number 5, if I convert hexadecimal, I got 5. No. I had to keep my answer in 2 digits. So, the same number to write in 2 digits, I can add a 0 in front. But the value is same, but I have 2 digits. Is that clear? I add a 0 in front to make sure 2 digits. Again, 27, if I convert, I have the answer as 1B. So now what I can do is I can write my hexadecimal color code as hashtag D8051B. Is that clear? If you miss the hashtag symbol, what will happen? Without the hashtag symbol, your answer is wrong. Because we're not representing now. For example, when you're writing a number, we write like 27 base 16, right? To represent a hexadecimal number, base is one way. Apart from base, another way of representing hexadecimal number is using hashtag in front. Make sense? Anything else? Okay, perfect. Surya, regarding that operating system question, can you stay? I'll pray and come and tell you. and paste it. Click this. 5 minutes more. Okay. Okay. Bye, Hadra. Give me back. Few minutes. I'll be back. Bye. Okay. Surya, are you here? Okay, perfect. Give me a moment, right? What do you call Suraya? In terms of CapCut is normally used for video editing, not photo editing. And in terms of the gallery app means I'm saying the normal photos application. So through the normal photos application itself, you can do those changes, the small retouchings. Or else there are applications like Lightroom, or else there's another one called Snapseed or something. I can't remember exactly. The basic stuffs. Okay, in terms of utility softwares. So basically, when you take operating systems, okay, in the operating system lesson, there is a topic called software which you all learn. Okay, so there is a topic called software which you learn. So under this topic called software, give me one more minute. Just not remember this as well. Country. Okay. So what do you call when you take softwares, you can classify softwares into two main categories, right? One is what we call as the system software, and the other one we call as the application software. So the main difference between system software and application software is system softwares are the compulsory programs that your computer needs. And if you talk about the other hand side about application softwares are the programs you can, it's optional. If you want, you can download and use, but it's not compulsory. It's like, for example, needs and wants. System software are like needs for the computer. Application software are like wants for the computer. Is that part clear? Okay. Now, in terms of application software, already this WhatsApp, Viber, Instagram, Chrome, any application you might download and install for your benefit, those all come under application software. Now, in your phone, you have the settings application, and in your laptops, if you're using, there's some application called Task Manager. All those applications, is it compulsory needed? Like, for example, in your phone, you have the settings app, right? Is settings an app? Is it a compulsory needed application? Yes. Without that, you can't use the phone. So settings kind of application, those comes on a system software. WhatsApp kind of applications comes on application software. Is that clear? Perfect. Then in terms of what you called the system software, you can classify. Now, there are several softwares we have on the system software, but we can further classify this into three categories. Or we can group these system softwares, the compulsory softwares, we can group into three categories. One is operating system. So operating system is one of the important softwares we have. And then we have something called language translators. So language translators are those, what do you call, softwares we have that translates from one programming language to another. So if you're wondering why is it needed, at the end of the day, your computer can understand only binary values. So there is a programming language that's made using binary values only, and we call that programming language as machine language. So there is a programming language called machine language. In that language, we use binary values only. So your computer can understand only machine language, but as humans, it's difficult for us to code using machine language. So what we do is we code in a language where you have used English more. And what happens is that language which you code is converted to machine language, and its conversion is done using a language translator. So do you know what are the three examples we have for language translators? So we have three examples for language translators. One is assembler. Then we have compiler. One more is there, or the other one. Assembler, compiler, and interpreter. So these are three examples we actually have. So assembler is a translator that's used to convert from assembly language. There's a programming language called assembly language. So from assembly language, if you want to convert to machine language, for that we use this translator called as the assembler. Okay. And then if you want to convert from program, like for example, if you want to convert from high-level programming languages. Now, high level is a category. Under high level, you have Python, PHP, what do you call Java, Pascal. They all are examples that come under the category of high-level programming language. Okay. So when you want to convert from high-level programming language, you can use either compiler or interpreter. High-level programming language, you can use compiler or interpreter. Do you know the difference between compiler and interpreter? How they function? So basically, the main difference of using compiler or interpreter is basically that when you use compiler will convert the whole code at once. What I mean by whole code at once is, let's say you have a code, and let's say your code has 1, 2, 3, 4, 5 instructions. So what your compiler will do is compiler will convert all 5 instructions at once, and only if all 5 are converted, then you can start using the program. But if you take interpreter doesn't convert all the instructions at once, correct? It will convert step by step. So it'll convert the first instruction, done. Go for the second instruction, done. Third instruction, done. Fourth instruction, done. So if you're asking what is the advantage of using an interpreter compared to compiler, let's say in the code, there's an error in this line. Okay, let's say this line has an error. Now, if this line has an error, the compiler will try to convert the whole thing. No? It will be like, I can't convert the whole thing because this line has error. So the whole code does not get converted. But if you use interpreter, let's say this line has error, what it will do is, again, it depends on the error, okay? There are certain situations, it will convert at least only these two and give you. Sometimes what it will do is, it might convert these two as well as the ones after that. It will be like this line has an error. And leaving this, it will convert the ones that are possible to convert. So whatever is possible to convert, it will convert. Whatever has error, it will be like this line has error. Because it's converting line by line. Have you clear the difference between compiler and interpreter? Perfect. So that's the language translators we have. Now, apart from that, the final category we have for system software or compulsory software are what we call as the utility softwares. So utility softwares are basically softwares we have in our computer for our purpose to make our work easy. But again, it's something that we have to compulsory have. So for example, in your laptops now, you have this application called Task Manager. Using Task Manager, you can go and see what are the applications that's currently running in the background, how much of memory it's taking, how much of processing power it's taking. So using task manager, you can go and observe all the steps. Then you have the option to copy paste values, right? Copy pasting values. Are you using a laptop or phone? Phone. In when you take laptops, copy pasting values, you can copy multiple values. Okay. Copy pasting values in laptop, you can actually copy paste multiple values. So what I mean, even Android phones you can, iPhone you can't. So for example, let's say I copied this value. I first of all copied this value. Okay, Control C. I copied this value, Control C. Now, first I copied this, second I copied this. If I go and paste, the last one I copied is already there. So when I'm pasting, the last value I copied is already there. So there is a way where you can get the old values as well, which we call as clipboard. In Windows computers, it comes as the Windows key plus the letter V. Okay. In your Windows computers, you can press the Windows key and the letter V. Okay. When you press that in the keyboard, there's a Windows key and the letter V. If you press both of them together, okay, if you press both of them, this key. Okay. This Windows key and the letter V, if you press both of them together, you get something called clipboard. So here you can see all the values what you call copied, the one you copied recently, before that killer, the collection of all the values you copied will be visible like this. All the values you copied will be visible. So now clipboard is also a software. It's there within the computer. And these are essential software that comes within the computer itself that makes our work easy. Okay. We can select all and copy, right? No, that's different. What I'm talking about here is when you copy multiple words. Now, for example, let's say I copied this word first. Okay, let's say I went and copied this word first. Then I copied this word second. Okay, then I copy the whole sentence third. Now, when I paste, what will get pasted? Will the windows get pasted or clipboard get pasted? The whole thing get pasted. I first copied this, second copied this, third I copied the whole thing. Exactly. It will paste on the whole thing. It won't paste the part I want. Okay. But let's say I copied this, then I copied, let's say the word called Google here, or the word called, let's say AI, let's say copied another word as well. I copied the word called 5 Windows something. We just go for a random page and copy some text. Let's say I copy the word called the Windows. I copy the word called feature. I copy the word called items. Now, when I'm copying multiple words like this, it will remember what the last word I copied, or when I paste, it'll paste everything. Hmm? And I go and paste the last word. See, by default, if I go and paste, it'll paste the last word. It is a clipboard. But let's say if I want to get all the previous history, you can get the previous history using this option called clipboard. So let me show you clipboard in my laptop today. So in my laptop, clipboard works a bit differently. So if I press Windows here, then my one is different. You can see in my clipboard, it's showing you here all the values I copied. Makes sense? So this copying history is there in an application called Clipboard. So Clipboard is an example of a utility software. So likewise, there are some utility softwares we have in the computer that's there to make our work easy. It's a compulsory. When you buy the computer, by default, it will come. So those by default softwares are what we call as utility softwares. For example, your phone settings application is actually a utility software. Got it? Any other questions? Oh, okay. Okay. So as there's no other questions, I'm going to end the meeting. Have a nice day. Bye bye.